Good morning, all of you. Welcome from College of Engineering, Fulton. Today we are going to perform practicals on CNC machines, of course, SY Diploma Mechanical. Myself, A.K. Dudhar. Today we are going to perform practical number 1, that is the facing operation on CNC lathe by linear interpolation function. Here we can see that the image of the CNC machine in our workshop. The CNC machine in our workshop is the company of high-tech company. Here we see the overview of the CNC machines. CNC machines. Then next aim of our practical is to facing operation on CNC lathe by linear interpolation functions. Here we can see that the facing operation image, how to do facing operations. The facing operation is the basic techniques, basic turning operation used to produce a flat surface at the end of cylindrical workpiece. Next we can see that the instrument required for to perform this practical, the apparatus required. First is the CNC lathe machines, second is the mild steel workpiece, that is the raw material required for processing. Then next is the single point cutting tool, the tool required to perform process. Then tool holder, here we can see that the images of all these instruments. Tool holder is used for holding the tools, and here we can see that the multi-point cutting turret is used. Here we can attach multiple tools at on one turret, and we use for the processing. Then control panel, and then next is the measuring instrument like vernier caliper. It's used after the processing of the instruments. The material used in this practical is the raw material is the aluminum, and the cutting tool is single point cutting tool properly mounted in the turret of the CNC machine, and workpiece is securely clamped in the check. And we can see that facing operation removes material from the end of the workpiece to make it flat and smooth. In CNC lathe, facing is performed by moving the tools along x-axis using Z01 linear interpolation while spindle rotates. Then we can see facing operation on CNC lathe by linear interpolation. Here we can see that the diagram of facing operation. Here we see that the raw material given diameter is 25, given length is 100 mm, and we have to facing operation done on one side, that is 1 mm. Where first we can see that the axis identification. The spindle axis of the CNC machine is always called as the Z axis. Here our machine is the CNC lathe, hence our horizontal axis is the spindle axis, that is the Z axis, and the perpendicular axis to the spindle axis is the always X axis. Here we can see that the points A, B, C, D and E. Here A point is the home position of the tool. At that point there is a specific coordinates. And then after that we can see that at point P, tool move from point A to point B, where at point B there is x coordinate is 0 and z coordinate the 0, 2, that is 2 mm tool is long from the to our workpiece, and at point C there is a workpiece 0 point, the both coordinates are the 0, 0. After that D point there is a coordinates is x coordinates 25, that is our diameter given is 25, and at Z there is a 0 dimensions. After at E point we have to do 1 mm of the cut, that's why x coordinate is -1, that is our z coordinate is -1 and x coordinate is the 25. After that, after processing we have to go for home position, that is at point A. and at point A there is coordinate is 25 and 2. After find outing coordinates, so I have to do program for that specific operation. We can see here program for the program for above processing. N01 we can see that first line N01 M03 S2 2000. Here M0 is the sequence number of the program, M0 is the spindle start, and yes 2000 is the speed given of the machines. Then we can see second line N02 G00 X27 Z2, where N02 is the sequence number, G00 is the rapid travel, that is there is a movement of the tool but there is no removal of the material. Then at from home position tool movement is at home position A tool movement from A point to the point B, there where there is coordinates is the 27 and 2. After that next we can see the NO3 G01 is the linear interpolation. At point D we have to perform the actual machining process. From point D to E there is the facing operation, that is the Z -1 and X is 25. We can say that here actual machining process is Z-1 F60, that is the feed is given to the system. Then N04 G01 X-1 F60, X-1 is the vertical movement of the tool is given. Then next N05 G01 X25, after processing we have to take your tool at the home position. N06 G00 and Z2, N07 M05 means that is the spindle off, and N08 that M30 meaning that there is a program end. Here is the basic program for the facing operations. Thank you. After preparation of program, we can see that this program in cut viewer turn actual simulation of the tool. Then we see the simulation software. In that we can first see the cut viewer software, open cut viewer software. Then we go in file, open your program, and then we can see that here we can see that our raw material is given. Here we open previously saved program. After that we see in detail how to write program and how to run program. In setup we have to given dwell time for understanding simulation. We have to increase the time of the simulation. After that we can run. In that we can rebuild the program, and here we can set that the movement of the tool. And here we see that the tool and there is a movement of the tool, and here we actually see that the facing operation of the facing operation. Then next we can see the how to write new program. That's why we have go to file in new. Then we have to take program window at the left. We can here write program. After writing program we have to run that program, rebuild. Here one tab is given, that is no tool found, do you want to be defined, then yes, okay. That where we can see that the simulations of the tool.